Ladies and gentlemen, it's my pleasure to introduce our speaker today, Nicholas de Monchaux, who's a professor at Berkeley in architecture. And he is going to talk about a very interesting topic, merging land use in urban areas with various aspects of participatory sensing and modeling and use of information technology. He's author of a book called Spacesuit, Fashioning Apollo, which is an architectural history of the spacesuits that the people who walked on the moon moved. So you can see that our speaker has varied and interesting interests. So now he's an architect and urbanist who's focusing on nature, technology, and the city. So with that, I will turn the floor over.
Well, thank you very much, Steve, and thanks everyone for turning out in the middle of what I'm sure is a busy day for everyone. It's a pleasure to be here. So let me talk a little bit about what I'm going to talk about, which is, to set the stage, I'm an architect talking about technology in the city. And if you know anything about architectural history, that's not a new thing. But if you were to be listening to an architect talking about technology in the city 50 or 100 years ago, 100 years ago it would be someone like who you may not have heard of, like Robert Geddes or Ebenezer Howard. 50 years ago it might be someone like Le Corbusier or Walter Gropius. And what they would have presented to you would be really a utopian vision of what technology can do for the architecture of the city. I'm not presenting a utopian vision to you today. I'm actually trying to present the reverse, which is to say, to think really about the space that exists between how we would like to organize the city, whether through a utopian vision or even something as everyday as a property map, and then attempt to occupy precisely that space between how we imagine the city and how the city actually is. So let's consider a little bit about why such an effort, especially one, as I'll show you today, focused on increasing urban resiliency and robustness, might be necessary. These are the only graphs I'll show in an engineering school, but they show a couple of different data points. From as a white guy showing slides, I have to show you another white guy showing slides in the form of Al Gore, the gap between peak oil and energy usage, and of course the growing urbanization of the planet. If you haven't gotten this particular memo, sometime last year someone was born, probably in South Asia or Africa, and the world became more urbanized than it was rural. That is to say, there are more people living in cities than not. Cities consume 75% of the world's energy and emit 80% of the world's greenhouse gases. Barcelona, a city like Barcelona, only needs 64 gallons of petrol per year per inhabitant to sustain its current growth and movement patterns. Anyone want to guess what the same number is for Atlanta? 260? 782. So there's at the same time, as our cities are, especially in this country, are highly dependent on dwindling resources, global climate change is already ensuring that the 500-year storm is becoming the 50-year storm, and the kinds of centralized, resource-intensive infrastructure that we've built our cities up with are, it turns out, those least able to cope with change and climate change in particular. So the main question of 21st century urbanism is how best to build resilience in cities, and not just in cities that we're building now over the globe, but cities that already exist. So now I'm going to show you my small proposal against this large background. This project, called Local Code, considers that in a world ever more subject to digital sampling, measurement, and position, one of the most essential opportunities might be not, as is currently the architectural fashion, to seek more and more systems of order, but rather to better examine and instrumentalize disorder, disorganization, and as I said before, the difference between the world as we structure it conceptually and the world as it actually is. Local code is an urban design proposal. It identifies legally and socially abandoned urban sites and imagines their transformation. It uses emergent digital methods to create out of undocumented and marginal conditions a potentially crucial social and ecological resource. Every citizen. Oop. One precedent for this work. That's from the soundtrack that you can see online. One important precedent for this work is the territorial artwork of Gordon Matta-Clark, an architect and artist. Between 1971 and 74, it took Matta-Clark months of sifting through microfiche to find 15 gutter space sites, isolated and demapped fragments of urban real estate. Using a contemporary geographic information system, or GIS, it takes a few minutes and the same search locates thousands of marginal city-owned vacant lots throughout the 5 boroughs of New York. When Matta-Clark, who's a well-known artist, first presented these projects, the mere fact of these sites' existence was cause for attention. Spaces between places, in Matta-Clark's terms, they were also kind of fissures between material and information space, between the world as the city's property map projected and the world as it actually is. I make the argument today that this artwork from the 1970s is potentially essential in considering how we might respond to both the increasing ubiquity of geospatial information and the larger issues of urban resilience and change that I talked about initially. And New York, as it turns out, is not unique. If we look at other American cities, we see a similar pattern. Thousands of remnant parcels and hundreds of acres of fallow public land. Before the advent of digital mapping, we couldn't perceive this resource, or let alone analyze or exploit its potential benefits. The rest of the work I'm going to show you today mostly focuses on San Francisco, where we've identified over 1,500 city-owned remnant parcels throughout the city grid. Many of these are so-called unaccepted streets in the city's terms, sites in the San Francisco grid which occupy the position of streets but are not maintained by the city or necessarily even passable to traffic. Seen separately and individually, these are litter-filled residual spaces condensing around highways and other public sites. When accumulated and considered together, however, these sites can be seen as a common and collective resource. Such a vision becomes especially important when we deploy mapping technologies to study more traditional understandings of neglect and decay. In San Francisco's case, these sites we've identified outline a kind of awkward penumbra of divisive urban highways as well as the shape of entire neighborhoods that are off the map. When we map things like carcinogens, reported crime, use other more sophisticated social science tools to map priority need, we actually find that these sites are already in precisely the parts of the city that need help, not only socially but also ecologically when we look at things like a heat island analysis, a study of clogs in the city's sewer system, etc. It shouldn't surprise us that what's off the map is also precisely in the part of the map that needs the most attention. These sites have a combined surface area of more than half of Golden Gate Park and 2/3 of Central Park. And they're an untapped, if you haven't got the point already, they're an untapped resource. What we've done then in the project is take each of these 1,600 sites, and this is what you see going on in the upper right-hand corner of these video segments, and then applied, we haven't attempted a sophisticated social analysis, but we have applied architectural thermodynamic analysis tools to basically understand how one would configure, through a parametric design process, or what's called a parametric design process, configure permeable and impermeable surfaces, trees and so forth, around each site to best reconstitute the site's ecological contribution to the city as a whole. Let's talk about money. The financial model, this of course sounds like a great idea, but lots of things sound like a great idea. But we've made a substantial effort to understand a financial model of how such a renovation might be able to work. What we propose here is a kind of inversion of traditional flows of resources. using a network analysis model of cost benefits, we've proposed that each intervention be funded according to its contribution to urban performance. So for instance, as about one example, the city of San Francisco is currently floated a multi-billion-dollar bond measure to upgrade the combined sewer system and get rid of those clogs that we showed on the map earlier. Using established engineering metrics, we've shown that using less than half of these funds for a upgrade of these surface sites in the city, which are well located to act as permeable sites and sites for water retention, the city could decrease the capacity, decrease the effect of each peak flow event on the city's stormwater system such that this massive upgrade wouldn't in fact be necessary. And not only that, but because it's all water and it's easy to model, we can actually understand how much each site would contribute to that savings and then project that each site could and should be funded to this level of, to a specific level of financing. And just as to imagine what that is, it works out for this massive set of sites, the size of half the size of Golden Gate Park, it works out to about $600 a square foot, which is, you know, for any architects or engineers, is about 2 or 3 times what you spend on the most expensive park. Working with my colleagues in the Berkeley Center for New Media, we've looked also at how a system might be layered over these more practical and pragmatic concerns to allow community engagement and the precise configuration of resources on each site within the larger limits set by the system. So what we're proposing is not only a network of spaces in the city, but a network of places, that is to say, sites of meaning and character, at least where communities choose to engage with such a process and imagine their own participation. So what you end up with is that just one visualization is not only one site, but then also a whole number of sites on the city, on the scale of the city as a whole. And the notion here is that we can move beyond the kind of heart and lung and circulation metaphors of 19th century urban planning, which still very much live with us, to a kind of network model whereby such a system might be a kind of distributed immune system to perhaps create another architectural metaphor for the 21st century city. So with that, let me talk a little bit more about background, precedents, and what this all might mean. This project draws from many existing precedents in green alley, such as green alley programs in Los Angeles, programs in Chicago and Baltimore, and then even in San Francisco, where an existing pavement to park program has been put into place, coinciding with our work as well. But our proposal offers an essential critique of this existing practices too. If local code, this project uses what Gordon Matta-Clark, the artist, called spaces between places. An essential caveat is provided by Matta-Clark's own attitudes towards urban planning. It turns out that his father, Robert Matter, worked for 2 years in the studio of Le Corbusier, if you know who that is, and the famous modernist planner, and rejected his work as suitable only for a non-existent creature that lived in perfect harmony with the society in his work. Matta-Clark traced his own interest in adaptive reuse to the observation that the availability of empty and neglected structures is a prime reminder of the ongoing fallacy of renewal through modernization. And so it's important to understand that what we're attempting here is a kind of turning around of not just traditional media of property, but it's new media as well. And the new media of property is GIS. And GIS has a very interesting history. It was developed initially for America's post-war nuclear defense, and then forged in a mid-century optimism of systems-based planning, in and around cities like New York and Los Angeles, where cybernetic models of cities, dynamic models of cities were all computed as such systems were developed. Matta Clark himself saw the potential of these systems and actually wrote to the GIS laboratories at MIT and UCLA before his death in 1978 to attempt to use some of the same systems for his own work. Half a century later, we are actually inundated by digital information about place. And for all of you with a Android phone in your pocket, you already have the ability to browse and understand an astonishing amount of information about place. Our problem is now not too much information, not enough information about place, but too much information. And disciplines like architecture have to figure out what to do with this information and how best to connect it to existing modes of practice. An interesting thing has happened in architecture in the last 10 or 20 years related to digital models of practice, which is to say an ever more virtuosic use of digital systems like CATIA or AutoCAD's Revit to produce incredible systems of organization within the scope of the building. And one of my, precisely because architectural software is constructed to allow you to do a lot of stuff within the envelope of a building, it's not constructed to allow you to understand what the potential contributions or costs of an individual building are to larger ecological and social systems. And the nature of this software has made architects turn not to a larger understanding of systems, but turn back to certain architectural movements in the 1960s and 70s that actually became very preoccupied with the internal mathematical order of buildings and not with the social or political role of buildings. Gordon Matta Clark had those folks as his teachers, Peter Eisenman and others, at Cornell University from 1962 to 1968. And to say that he held their methodology in disregard would be an understatement. Most famously, he destroyed the windows of Peter Eisenman's Institute for Architecture and Urban Studies with an air rifle when invited to exhibit there in 1972, deliberately intentionally recalling the abandoned and decaying housing structures of Brooklyn and the Bronx that were, to this artist, the legacy of a kind of high systems modernism. In search of an alternate model, we might turn to one of Matta Clark's last unfinished works, which was the physical construction of a community center in an unused site on Manhattan's Lower East Side, for which he was preparing a proposal at the time of his death in 1978. Here again, I'd also remind you of our own speculations with the BCNM on how digital media can be instrumentalized to help develop an archipelago of community-based projects across the city. Now, we don't have any real record of these of what the actual design of these spaces that Matta Clark was designing at the time of his death, community spaces, actually looked like. So we can only speculate that some components of the initial proposal looked like they were drawing precisely from the very mathematical, geometric, and spatial calculations that governed the kinds of remaking and kind of occupation of abandoned sites artworks that Matta Clark was making around the time of his death in the 1970s. This is Day's End, which was a series of parabolic incisions into a warehouse, abandoned warehouse on the waterfront in New York. And this is a project called Office Baroque, which was a series of complex mathematical cuttings into an abandoned office building in Antwerp in 1977. In the case of our project, I've shown you a lot of geometry for sites in the city, but it's important to remember that just as Matta Clark might have used such geometry, it's only the very first step in engaging a real social and political process of urban transformation. In this vein, Matta Clark himself described the audience for his work as precisely a network of community groups and individuals engaged in open space and rehab projects, sweat equity, community gardens, play lots, cultural events, and alternative living structures, adding that his proposal has brought all these groups together. Now, Matta Clark's use of the word network is particularly interesting, at least to someone like myself. Here's our projected network of sites in San Francisco, and here is, for those of you not used to what the avant-garde or the state of contemporary architecture is, here's a lot of what's happening in my field today. And what's especially interesting about this type of work is it's all driven digitally using the kinds of software that I was talking about. And Yet the language that architects choose to describe such work often borrows from biology, using words like emergence, morphogenesis, phylogenesis, etc., etc. And architects get really excited about these sorts of words and this sort of vision of nature as computing form from code, because they like to think of, you know, if DNA is the blueprint of life, then architects make the blueprint of the world, and we might turn to these kinds of models in an attempt to understand what to do with all these new information-based abilities that we're gaining to make form. But I don't think this is quite right. I think it's actually very important to remember that urban history and the study of nature and networks and self-organization have actually had a much longer history of mutual influence. One of the earliest critics to connect biological theories of emergence with an understanding of the nature of urban and infrastructural systems was also like this guy, Matta Clark, I've been talking about, a student of Manhattan. This is, of course, Jane Jacobs. Now, because I'm not necessarily sure of this audience, how many people have heard of Jane Jacobs? So I'll tell you a little bit about who Jane Jacobs was. Jane Jacobs was a uneducated, so to speak, she wasn't college educated, stenographer from Scranton, Pennsylvania, which is the place where they hold the office, which means that it's not a very big, not a very distinguished place at all. And Jane Jacobs came to New York in the 1950s, ended up with a job at a magazine called Architectural Record, first as a typist. Then they discovered she could write. She could write really well, and they commissioned, and of course she was this girl from Scranton who was in love with New York, and in love with New York, how New York actually worked. And she wrote a set of really amazing little pieces at the back of this magazine, Architectural Record, about how the city actually worked. The state of architecture and urban planning was such at the time that she was the kind of ended up being the sort of figure who said that the emperor had no clothes as far as these larger theories of urban formation. Now, could I get the same show of hands for Le Corbusier? I just don't want to be talking about people who have no. So Le Corbusier, a very important French architect and planner, really thought about the city as a system. It was like a circuit. The circuits needed to be clear for information and people to travel around. And what this meant, chiefly as far as urban planning concerned, was roads, roads, and more roads. Corbusier's great disciple in New York was a guy named Robert Moses, who you probably have heard of. Robert Moses proposed, built lots of great connective tissue in New York, but he really he let himself get away with this, is an understatement. And at one point, he wanted to build a highway. This is where the two stories come together, right across Jane Jacobs' house, a giant 8-lane expressway across the neighborhoods of the Lower East Side, Soho, and the West Village, which may sound to you like a completely absurd idea. Just for the real estate prices of those neighborhoods alone, but at the time was considered the state of the art in planning. Jane Jacobs is an urban activist, got upset about this. She helped organize a series of sit-ins and public meetings that scotched this project, but then she got interested as a really sharp mind in why these theories of how the city worked were so popular and led to things like this hybrid proposal, and why people didn't understand how the city did actually work, and so which is what she'd been writing about. So the Rockefeller Foundation funded her to turn these thoughts into a book. The book is called The Death and Life of Great American Cities, and it's kind of like the Silent Spring of urbanism. It's a book that was very controversial when it was first published, but is now accepted as kind of a foundational text in understanding how cities work, and it describes how the complex emergent systems by which a city makes itself, and how, amongst other things, ramming highways through isn't such a great idea. What's especially interesting to a student of the history of science, is that Jane Jacobs, at the time she was writing this, was sharing an office with a very special guy named Warren Weaver. Warren Weaver was trained as a mathematician, and he'd retired at that point from being head of Memorial Sloan Kettering, where he became acquainted with the state of the art in biology, and he led an initiative of funding by the Rockefeller Foundation starting in 1955 on the funding what he called the science of organized complexity. And if you trace the intellectual roots back, a lot of what we now accept today, as far as the study of nonlinear systems, chaos, dynamics, etc., come from can be traced, at least in part, to this initiative. And this was the person Jane Jacobs was sharing an office with. What does this have to do with architecture? Well, in my mind, what's interesting about today's architectural, all these searches for ever more virtuosic systems of order, what they threaten to fail to understand is that architecture mostly and increasingly takes place in cities, and cities are not places of perfect order at all. Cities are places of messy adaptation, change, and in fact this is precisely what makes them work. If I can drop another science reference, probably most people in this room know who Stephen Jay Gould is, and Stephen Jay Gould cautioned his colleagues in evolutionary biology against assuming that nature was too much of a kind of optimizer, and he used an architectural example, which were the spandrels in the Byzantine Cathedral of San Marco, which were these triangular spaces that happened to exist between the geometry of a dome and the geometry of vaulting. And no one would ever, Gould said, say that these triangular spaces were precisely put in place to allow for triangular paintings to be put into them. I mean, they were kind of adapted, but they weren't the cart wasn't leading the horse. But architects tend to do that a lot. Architects tend to assume that anything is optimal. There's a huge movement, even on this campus, for bio-inspired design, biomimetic design, and there's a lot of good work to be done in that area. But I think, especially when it comes to working in cities, we need to be a lot more careful about, as I say, assuming any kind of optimization, a lot more open to questions, to opportunities for adaptation and change and what an evolutionary biologist would call an adjacent possibility. That is to say, something that's very close to where we are now, but might be a lot better. That is the most theoretical that this talk will get. Everything else is much more down to earth. I just want to show you, before I take some questions, how this work is actually progressing with cities. We're working actually in a very interesting way with the Department of Public Works in San Francisco to understand how this work can start to influence some of their work on water retention and drainage, and the Public Utilities Commission. As well as that, we've been working with a group in Oakland, Future Farmers, and a group in the geography department here at Berkeley, looking at how vacant public land in Oakland could be optimally planted for the provision of produce and groceries to a city that has a particular problem with the access to fresh produce in much of its neighborhoods. And then we're also working with a group, the Wildlife Conservation Society in New York, to understand how almost 5,000 vacant lots in Manhattan could be used to promote and restore native habitat in New York, as well as increase the ecological functioning of the city. The last piece comes a little bit more, including because it comes a little bit more into the realm of engineering. This is the video of an exhibit that we did this summer being fabricated. These are models of several hundred of the sites in San Francisco that I was talking about, of what their landscapes might look like if optimized for water retention and the presence of constructed wetlands. But in this, if you can understand it, or if I can explain it to you adequately, is a very one of the most important parts of this talk, which is a very different idea about infrastructure, which is to say, when we can design and fabricate mass customized infrastructure, infrastructure can do a lot more for us, and it can do it very differently. That is to say, most infrastructure we have created in the last century has been based on a one-size-fits-all model and on a notion of giant tubes, standardized tubes that bring resources to us and help ameliorate the effect of our waste on the environment. But very crucially, in today's environment, we have the opportunity to do something very different, which is to say, to use some of the tools we have to understand geospatial, using geospatial tools, the thermodynamic and drainage properties of each individual site in the city. And we can also use some of the tools that we've developed as far as mass customization, parametric design, and so forth, to really imagine how imagine the whys and wherefores of how each part of the city can be the best citizen of the city and be the best contributor to the to the public welfare. That's all those models together, and that's the end of my talk. Thanks very much. This is my first time giving this talk to quite this cross-section of audience. So if there's anything you didn't understand, B, violently disagree with me about, or C, would just like to get off your chest, please put up your hand.
Could you give us one or two concrete examples about the kind of lots that you found in San Francisco and what you plan to do with it?
Sure. Well, I don't. It's very difficult for me to plan to do with anything because the city owns them, and so. But if you really, there's basically at least three different kinds of. Well, let me back up. The only way the people who'd done all the work finding these lots for us turned out to be the Department of Public Works. The Department of Public Works didn't have a database of these lots as a resource. What they had on someone's computer was an Excel spreadsheet with that listed every single tiny piece of land in the city that if you called up the Department of Public Works and said, there's a problem here, there's a couch burning, there's, whatever it is, they would say, oh, we don't do that. That's unaccepted. We don't have anything to do with it. So it's very difficult to generalize about what these sites are. I tried to show you just a small photographic survey of them, but you can basically understand them. They're little triangles of land that go between the regular grid of the city and the highways, or they're, for instance, a lot of them in San Francisco are what are called paper streets, which is to say what makes San Francisco wonderful and crazy as a city is that this grid is dropped down completely irrespective of topography. So quite often in a lot of neighborhoods in the heights of the city, you have a piece of land that's zoned as a street or as a right-of-way, but it's actually impassable to drive on, so it's just there as a, normally with weeds, or occasionally the neighbors have tried to do something, but that's only a kind of sampling of them. It's like trying to generalize about what the nature of trash is. Well, you can make some, this is like junk space or gutter space is what Matta Clark called it. But if I've said anything today, hopefully I've said that we can't afford to, just as we can't afford to look at any part of what we do in a kind of cycle of consumption as trash these days. We have to always look at how we can use something as a resource. We can't afford to look at any space in the city as trash and not imagine how it could and should be used as a resource. Does that answer your question?
No, not at all.
Okay.
I understood the generalities that you presented, and you repeated some of those. What I would like to see is just one or two specific examples where you show the photograph and says, here's one of those corners. Look, this is bad, that is bad, and so on.
Okay.
What you could do, we put some grass here, we put a bench here, we make a statue or something. If everything that you showed was at such a small scale and such a distance that not one of these images, sticks really in mind and shows what's going on.
Okay. Let me try and show that to you. So I think this is the right slide. It may be a little hard with this dim display, but in the center of this presentation, we did try and look at this one street, it's an unaccepted street called Revere Avenue, and it's in the south side of the city. And it's currently used as a kind of parking lot, and there's an occasional car that goes around it, but it's actually not open at the other end there. And then this is the wind speed analysis of where the buildings need shelter from the wind. This is a kind of solar analysis that shows where a low albedo coating could be best distributed to help with the urban heat gain. And then this is stands in for a kind of water analysis that doesn't produce as nice visuals on where retention is needed. And then if I can freeze the video. Hold on. So let's move the video along, and I can hopefully pause it before. And so in this case, now it's very hard for me as an architect, especially given this history, to say, here's a huge part of land of the city, and it should all be here. There should be a footpath here. There should be a a playground here, there should be this, there should be that. Because what we've learned in the last 50 years is that cities only develop really well if you engage everybody in such a process, and if you allow for the possibility of what you suggest as a designer won't necessarily be accepted or will be transformed by the vision of what's people there. So what I feel comfortable doing is what I've done, for instance, on this site, which is to say that, well, given the basic topography of this site, the basic distribution of buildings around it, here's a suggestion for, in this case, this center part of the street here is the same as the white part in those models, if you remember. This is a kind of a drainage channel that takes water from the neighborhoods around it and takes it in here and puts it to a retention pond that's here at the bottom of the street. This is a kind of a windbreak with trees on it. This is the prevailing wind comes from this direction, and just by putting, especially in a windy city like San Francisco, just by planting in front of buildings, you actually reduce the heating load on those buildings enormously, because there's an enormous amount of kind of quasi-evaporative cooling that happens with wind. And then what we've done is focus the green spaces and the non-paved spaces on those parts of the site where the sun is shining the most. And it turns out by just putting, I mean, Stephen Chu goes on about this all the time, but just by changing the color ever so slightly of, as it happens, a very well-distributed set of sites in the city as far as urban heat island, you can reduce by millions of dollars. Even in a city that's pretty temperate like San Francisco, the cooling load on the city by creating a kind of lower albedo urban surface. So does that answer your question?
It's coming closer. So
okay.
This will be primarily some kind of walk-through space.
Yeah. So it's in urban design terms, what we're proposing. One question I often get from a different kind of audience is, well, what do you do about parking? What do you do about cars? What do you do about if cars are using this space? And there's a larger movement. Again, this kind of way of thinking is much bigger than this project. But in the U.S., it's known as the complete street movement. In Holland, it's known as the Woernerf movement. In Japan, it's known as the House Street movement. And there's a larger movement in urban design towards public spaces not being divided in one stripe for. It's a very kind of modernist view that we have to organize the street and have a space for pedestrians, a space for telephone poles, a space for cars, space for parking, et cetera, et cetera. And instead, what turns out to work much better is a kind of open, a much more distributed surface where different parts of the surface can be used for different needs at different times, and the use is a more kind of emergent mode, whereas instead of saying, okay, this will happen here, we let all these groups negotiate with each other around public space.
Thank you.
Yeah. Yeah.
So in one of your slides, you had photographs that were being. So one of your slides, you had photographs that were being placed onto the picture, and there were red highlights coming up of these spaces. Now, I'm wondering what kind of techniques you used in the GIS analysis in order to locate those spaces, and what kind of pattern recognition or machine learning or whatever you used.
Well, there's at least two important strategies. One of them, the important thing to remember about GIS is always socially constructed data. It's very rare unless you're looking at like a raster, infrared data set or something like that you aren't actually getting information that's been made by somebody else. So oftentimes, especially with a kind of parcel map, it's a question of parsing whatever language the Department of Public Works or the Real Estate Office or the Zoning Board has used to describe to itself sites that it doesn't know what to do with. So you look for public ownership, and then you look for where the so in New York, for instance, we looked for publicly owned sites that were too small to suit whose size was too small for the minimum size of whatever they happen to be zoned for, which is a way of saying, a complicated way of saying these sites are, a small site in a piece of the city whereby what people have said you could do there actually takes too much space than is even actually present in that parcel. So it sort of falls off the map then. It can't be used for what it's zoned for, and it's just sitting there. So it's a lot of kind of detective work of saying, of applying different filters and trying to understand it. There's no, what I haven't done yet is treat them like you would treat, there's a whole more complicated technology in raster image analysis, for instance, that looks for, that's all been developed to try and find particular habitats, for instance, whereby, but, this is not like, a weed tree turns out not to be a very particular thing to be able to find, in an urban, I think that has less potential because, in some ways, because these sites are mainly socially constructed. And the important thing to remember, of course, is in most of the sites, something is already happening. It may not be legal. It may not be, a lot of kind of. So if you can look at, so more often than not, it's actually picking up the phone and really talking to people and saying, well, how in your parcel maps do you cope with sites you don't know what to do with? What code do you give them, et cetera, versus, and that's been much more successful than any attempt to kind of, come down from on high and determine algorithmically precisely where the sites are. Once you've got the sites, then you can do some, more digital analysis of them, because we know the heights of buildings, we know, the drainage surfaces, and you can actually do a lot of very interesting, more sophisticated modeling once you've got this kind of junk space to begin with. But the definition of junk space is social, and therefore it turns out that picking up the phone is the best way to figure out how and why to get at it.
Right. So just a quick follow-up. My follow-up question was going to be, what kind of error rate do you get on your analysis?
Yeah.
I was just assuming that you'd be calling places and they wouldn't actually be junk space. But actually, I think the more interesting question is, what do you think you're missing? How much more of this space do you feel like is there that your analysis is failing to pick up?
Lots, I'm sure. I mean, because if you're looking for, it's like trying to find. Trying to find anything that, by definition, doesn't tend to be caught up in various informational filters is always going to be a guessing game. You're never going to find it all. Trying to find poverty is the same kind of thing. Well, you can find people who have registered their income as lower, but you always know that there's going to be more people out there who are actually experiencing something. So it's but it's interesting, and I think if you were really trying to get at an exhaustive survey, you would be looking at it from several angles. This is only publicly owned land. There's lots of land that's in private hands that is not being used for anything, and onto which the city could kind of interpose a land banking, this is how these kinds of things happen. I mean, and it all depends on how you look at it. When I was, for instance, when I was a practicing architect, one of the projects that this is influenced by that I worked on was or when I was practicing full time, was the High Line in New York, which for many, many years was just a space that nobody thought of. It was just up there. People thought of it, we'll have to tear it down, et cetera, et cetera. And then it takes a certain design perspective to look at it and to say, actually, this is a valuable space. It could be this connective tissue. It could do all of these different things. And even then, it was only, a complex informational exchange whereby the air rights along the High Line were all computed and then auctioned off to people on either side, et cetera, and you could fund the thing. So it's an interesting, hiding in plain sight is a quality that these things tend to have.
So we'll do one more question over here.
So this may be a question about one of the aspects that your analysis can't touch. I'm not sure. But I've been really struck by the movement of the video when you're mapping the solar and water analysis and all of these things. And I'm also really interested in the connections that you're making with Matta Clark's work.
Yeah.
And one of the things that I've been considering a lot about Matta Clark's work is the relationship that he draws between those people who interact with his work and the architectural structures themselves, right? So the movement through space of the viewer in relation as a part of the architecture.
Absolutely.
So I'm curious, I'm looking, at these little shadowed images of people, and I'm curious if at any point in the analysis you're considering the movement of people through spaces, or when that consideration comes into play, if it's only after you're having conversations with community members, or if it can be factored into a digital analysis of spaces.
It's a really interesting question. One of the to the extent that I've been in this building before, it's because of the Center for New Media. And one of the reasons it's been so great for me since I've come to Berkeley to become engaged with the center is because I think it does come down to a question of media. And architects especially are both prisoners of and great exploiters of media, because we don't actually make buildings. No architect built, if an architect actually tried to pick up a hammer on a job site like this one, they'd be out of a job. Architects make drawings and now other kinds of media that other people use to determine how buildings should be built. And so you're always a prisoner of your media in that you could only design things that you represent to yourself. So it's always very important to me as an architect to make media that have motion, media that have time, especially because so much of architecture has suffered, especially in this century, for being seen as monumental and singular and not being transformed over time. And that's something that Matt Clark really understood. And he was a student of time and a student of how things changed in time and how things could be re-exploited through time, and buildings even through their life cycles and so on and so forth. So you can never be sure that you've taken into account everything, but you can make very deliberate strategic choices about what you represent to yourself, and that will that will very much control how you make spaces. None of this is really at the scale when we use the sort of cinematic eye in one of those videos to try and show what one site would be, but that would all be downstream of this particular design process. But it's very important, especially now that we can exploit things like time in different ways in media, not just to be still representing architecture in the same way. Because I think we're actually asking a lot more of architecture in time than we ever did. And the average lifespan of an American building these days is 15 years before a major renovation. So that's very low, and that means all architecture, more than it was ever true, all architecture is temporary. All architecture needs to take not only into account how people move through it with a cinematic eye, but what happens to the resources that it uses over time, what it leaves behind, et cetera, et cetera.
Okay, well, if you have any other questions, we can ask next. But thank you so much.
Great. Thanks very much for having me.